Welcome back to part 3 of the cross products topic in calculus 3. In this video we will talk about how we find the area of a parallelogram. Just let me remind you of what is a parallelogram. A parallelogram is a four-sided polygon where every two adjacent sides are parallel. So this one should be parallel with this one, and this side should be also parallel with this side. Now, in terms of calculus 3, it means this vector u and this vector v are parallel. So u and v must be parallel, which means their coordinate is multiple of each other. The angle between them should be 0 or 180. That's what we mean by parallel. So each two sides are parallel, we call it a parallelogram. Now for a parallelogram, if we want to find the area inside a parallelogram, we will take only the two non-adjacent sides, any two of them, and we will do the cross product, and then what we will get is a vector perpendicular to A and B. We will take the length, the magnitude of that vector. So it will take A cross B, and we will take the magnitude, and that will give me the area of a parallelogram. Let's jump to see this example. In this example, we want to find the area of the parallelogram enclosed by those 4 points. So those 4 points, A, B, R, and Q, they will give me a parallelogram. Means this side is parallel to this side should be parallel to this side. And we need to find the area of the parallelogram. So in order to find the area of the parallelogram, the best idea first is to have a little bit of a drawing here. So I have a solution. So we have the point A, B, Q, for example, R. We get kind of parallelogram. Something like this. Now what we need to find, the first thing, we need to find the two non-adjacent vectors. So I need to find this vector, I will call it U. I need to find this vector, I will call it V. And then the area will be just U cross V and whatever the answer is. So that's exactly what we are going to do. So just let me do it with a different color here. So first of all, I need to find, this is U, and I need to find V. So let's find each one of these separately. So the vector U will be just the vector that has starting point at A and terminal point is B. And in order to find this one, we have to subtract the coordinate of B minus the coordinate of A. So this will be 2 minus 1, which is 2. Will be 3 minus 0, which is 3. And then we have 3 minus 2, which is 1. So 3, 1. Now for the vector V, which has the starting point A and the end point, for example, R, we'll do the same. So we get 7 minus 1, 6, 5, and 6, which is 7 minus 1, 5 minus 0, and 8 minus 2. We get those two vectors. Now, in order to find the area of the parallelogram, all what we need to do is we need only to find the cross products. So the area of the parallelogram is, first of all, I need to find U cross V. So let's find U cross V. So U cross V, and this is equal to the determinant of I, j, k. In the second row, I will write the coordinate for u and v. What are the coordinates for u and v? 2, 3, 1. And for v, it is 6, 5, 6. We need to find this one in the usual way. So it would be something with I minus something with j plus something with k. Now I have to find the number in front of the I need to find the determinant of 2 by 2 matrix here, which is this minus this. So it will be 18 minus 5. This is 13. In order to find the coefficient in front of j, we take the cross product of the determinant of this matrix. So it will be 12 minus 6, which is 6. And finally, in order to find the one in front of k, we just have to find the determinant of what is remaining, which is 10 minus 18, which is negative 8. So this would be the answer. Now, in order to find the area, all what we need to do is to find the magnitude of u cross v, which is big square root of the squares of the coordinate. So it will be 13 square, 6 square, minus 8 square, and that will end up with the number here will be 269. And if we take the square root of 269, would be the answer. So that's the area. So here how we find the area of a parallelogram. Next example, example 12. In example number 12, we don't need to find the area of a parallelogram, we need to find an area of a triangle. So again, it would be a very good idea if we can have a little bit of drawing to find out, to figure out what we have and where we want to reach. So I have 3 points, they form for me a triangle, PQ and R here. So I have this, this. So I need to find the area of this triangle. However, if we look at this triangle, it is only half of a parallelogram. See this parallelogram? The whole parallelogram, which is this one, I know how to find the area. It will be u cross v, the magnitude of u cross v. Now, my original triangle is only half of the whole picture, of the whole parallelogram. So, what I will do, I will find the usual area of the parallelogram and I will divide it by 2. So, the area of my triangle is only half the area of the parallelogram. Now, what is the area of the parallelogram? It is half. It is u, if we do the same notation as before, u cross v. The magnitude of u cross v. Now, what is u? This is u. Take this one as u. And what is v? We'll take this one as our v. So we need to find u, we need to find v, we need to find u cross v, we need to find the magnitude, and we divide it by 2. Simply as simple as this one. So I would suggest that you can pause the video now, find u, find v, find u cross v, and find the magnitude. And then compare your answer with the answer that we will solve it after you play the video again. So we'll find u, the vector u will be, of course I have to write what is u here, So U is PR. So it would be 3, -4, and 1. As for the V, will be PQ, which is -3, 1, 2. That's the first step. Second step, we need to find U cross V, which is I, J, K, and then we write the coordinate of U, and then we write the coordinate of V, and we find the answer here, which is I minus J plus K. And how do I find the number in front of the I? I delete the row and the column of I, and I find the determinant of the remaining 2 by 2, which is -8, -2, this is -10. How do I find the number in front of the J? I delete the column and the row of J, and I find the determinant, which is 6, -3, which is 9. And finally, we delete the column of the last one, so it would be 3, -12, which is -9. And that's what we need to find as a last step, is the magnitude. So area of triangle is equal to half U cross V, which is half square root of -10 square, 9 square, -9 square. Whatever this number is, it would be 81, 81, and 100. So it would be half root 262. And that's the answer. Please check this answer against the answer that you tried the question by yourself and compare them together. So here the idea again is we need to find the area of a small triangle, and we notice that this small triangle is part of a bigger parallelogram. We know how to find the area of the parallelogram using the formula of the cross product. All what we need is to find the vector U and the vector V. Once we find them, we find the cross product, and then we find the magnitude, we get the area. Next is something very important called triple product. We have seen this one in a previous video where we have 3 vectors and we need to take the cross product between 2 of them, and then the result we will take the dot product. So it is the mix between cross product and the dot product. So we need to combine both of them. And there is a formula to do this. It will make our life easier. We can even go back to the previous videos and apply this formula. The formula is that it is the same formula for the cross product. We write the coordinate of P here, the coordinate of C here, but instead of I and J and K, we write A1, A2, A3. So instead of I, J, K, we just need to write the coordinate of A. So we take the coordinate of A and we write it here. Of course, here we write the B's and here we write the C's. We don't change them. So this is, we call it the scalar triple product. Now, this formula would be also used to find the volume of something we call it parallelogram. The parallelogram is if we have 3 vectors A, C, and B, it will form for me something similar to a cube, kind of a cube. We call it parallelogram, which means every adjacent vector are parallel. Now, if we want to find the area of the parallelogram, all what we need to do is we apply this formula, which is the triple product. It's a very easy, very straightforward, very direct. However, sometimes if we apply this formula, we might end up with a number 0, which means that A and B cross C, they are perpendicular, which means all those points happens to be at the same plane. The normal vector with B and C is also a normal for A. It means B and C and A are in the same plane, which means they don't form any three-dimensional solid. We call it coplanar, and that's why we get the volume equal to 0, because there would be no volume. They are on the same plane, on the same floor, the three vectors. We'll see it now in some of the examples. So here is the example. Find the volume of the parallelogram determined by the vectors A, B, and C. So I have three vectors and I need to find the volume. So we'll just go ahead and apply the formula. The volume of the parallelogram equal A dot B cross C, and this has a formula by itself. In the first row, I will write the coordinate of A, which is 1, 1, negative 1. In the second one, I will write the coordinate of B, which is 1, negative 1, and 1. And finally, negative 1, 1, 1. Now, we know how to do this. We take the first entry, which is in the place of the I, and we will cancel the row and the column that contains this number. So it will be 1. And then the second entry will do the same, and finally for the last entry we need to put negative 1. Let's do the first number, cancel the row, cancel the column. What's the determinant of the remaining? This is negative 1 and this is negative 1, so it will be negative 2. Next, cancel the row and the column, and we find the determinant, which is 1 plus 1, it will be 2. And finally, it is 1, negative, negative 1, so it will be 0. And I think the final answer will be negative 2, which is, of course, negative 4. So the volume will be the absolute value of negative 4, which is equal to 4. And that's exactly how we find the volume of the parallelogram. Please try to think about the question. It's very straightforward, similar to the cross product. Instead of having ijk in the top row, we will have to write the coordinate of the first vector, and everything will follow on the same way. Last question for this video is a question whether those 3 points A, B, C are coplanar. Remember, coplanar means are those points A, B, and C, they are on the same plane. Is there any plane that will contain those 3 points, or they are a little bit aligned from each other? Now, the idea is we need to use the volume of the parallelogram that appears here. But I don't have 3 vectors. So the first thing I need to do is I need to find 3 vectors. Vector A, B, and C. So what we will do, I will assume this is my vector A. This is my vector B. And finally, maybe with a different color, this is my vector C. So I have 3 vectors, I need to find them, and then I apply the formula for the parallelogram, and if the answer is 0, it means those were on the same plane. If the answer is not 0, those are not. So let me just try to find them first. So what is A? A will be just B minus A. So it will be 2, negative 4, negative 8. B will be 4 because it is C minus A. So it is 4, negative 1, negative 2. And finally, the vector C, which is C minus P, will be 2, 3, and 6. Now we need just to find the volume of the barrel. The pet, which is the triple product A cross C. And to find this one, we just need to apply the formula. So in the top, I write the number of A. Second row is the number of B. And finally, let's see. And now we need to expand this one and see what we get. So the first one is negative 4 here, negative 8. Now, how do we find the number in front of the 2? We have to cancel the row and the column for number 2. So we do this minus this. So it is negative 6, negative 6. So this will be 0. Nothing here. Check the second one. This will be 24 plus 4. This is 28. And finally, cancel this one, cancel this one. This is 12 plus 2, which is 14. If we put this all in the calculator, what we are going to get is the following. Zero. So, yes, the points A, B, C are coplanar, which means they lie on the same plane. Thank you for watching. Please like and subscribe, and if you have any question, write it down in the comments.